you. Thank you. All right, well, hello everyone. My name is Zach Waas Smith. I am a community engagement specialist with the Office of Sustainability, where I do a lot of work involving the sustainability of our buildings citywide. And I would like to welcome you to the first A2ZERO Sustainability Series of 2022. Tonight's presentation will be recorded, so you can watch it again if there's something you missed, or if you're currently watching the recording for the first time, welcome. Tonight, we're focusing on home electrification. We're going to give you some information and resources to prepare yourself to make the changes necessary in your home to electrify so that we can continue our work towards achieving the A2ZERO plan. Am I sharing my screen right now? Do y'all see anything? Okay, well, let me try that again. Now am I sharing my screen? Thanks, cool. All right, everybody, welcome to Everyday Electrification. And so we're gonna walk through some information tonight to help you with the information, to help you prepare to have the information that you need to electrify your home. And you should have all received an email with a worksheet in it that will help you identify the appliances that are in your home. And we'll be coming around to that in a little bit after we get to some presentations. I mentioned that this is a series and we have a number of others. And if you registered for this one, I imagine you know what the others are. But I also would like to introduce Sean Reynolds, who many of you know, and if you don't, you should. He is helping out with a lot of these as well. So he and I are sharing the duties on these, and he's got some really great ones coming up. So Sean, if you'd like to introduce yourself and maybe give a little teaser if you want to some of the things that you've got, go for it.
Sure, thanks, Zach. Yeah, as Zach said, my name is Sean Reynolds. I'm a community sustainability coordinator with OSI. And we are working together on putting together this series. So I will hopefully see many of you next month on February 23rd to talk about sustainable food and food access. And then I'll also be in charge of the one in April on air quality monitoring. So excited to see some of y'all at those. Thanks, Zach.
Thank you, Sean. So who can we expect to hear from tonight? Well, first of all, will be Henry Love, or Hank Love, as we call him. He is the director of Midwest Marketing Development and Strategy for Elevate. And Elevate is a nonprofit organization that wants everyone to have access to clean and affordable heat, power, and water in their homes and in their communities. Before joining Elevate Energy, he served as an executive director of the American Jobs Project, which is a nonprofit that he started with none other than the current Department of Energy Secretary, Jennifer Granholm, NBD, at the Berkeley Energy and Climate Institute. And we're also going to hear from McCabe, who is a contractor account manager, does work with code compliance and energy efficiency, and is representing Michigan Saves tonight. And Michigan Saves is the nation's first nonprofit green bank. They partner with contractors and lenders and funders to improve access to efficiency and renewables, diversification, carbon reduction, you name it, for residential homes and commercial property. Both of these organizations and these presenters tonight are really valuable assets to the work that OSI, the Office of Sustainability and Innovations, is doing with the work involving A2ZERO. And so we are eternally grateful for their hard work and very appreciative of their time to share with us tonight. But really quickly, before we jump into the presentations, I would like to hand things over to Mr. John Fornier of the City of Ann Arbor for some fun updates about ARPA funding.
Thank you. Hi, everybody. I'm John Fornier. I'm the Assistant City Administrator for the City of Ann Arbor. And I'm joined by Marty Prashan, our Chief Financial Officer. And you'll notice Chief Kennedy, our fire chief, also on the call. And we wanted to talk to you just briefly about the city's plans for our ARPA funding. As you may be aware, the city is receiving $24.2 million from the federal government, and we have published a preliminary plan on projects that we could spend that money on. And we're going to talk about a couple of those projects tonight, but we are currently engaged in our community engagement process to get feedback from Ann Arborites about how exactly we should be spending that money. And so, like I said, we're in the middle of the engagement process. We've had, I think, 10 public meetings at this point, probably more coming. We will have a survey published by the end of this week that we'll be asking members of the community to fill out to give us some feedback in writing. But we wanted to take the opportunity to talk about two projects in particular tonight that are sustainability related, that we're really excited about, that are eligible for ARPA funding and may end up receiving funding when City Council approves the final allocation of funds later this spring. And so, having set the table for that conversation, Dr. Stults and Chief Kennedy, do you want to talk about these exciting projects?
What a fabulous opportunity. Thanks for having us. And Chief, I'm going to have you go first, so I'll share the screen. Over to you.
Okay, well, good evening, everyone. Thank you for the opportunity today. So I really appreciate the time to kind of talk about one of two projects for ARPA funding. This one is to replace Fire Station 4, which is on the city's southeast side. There's currently a fire station there. It's on the north side of Scheffler Park. And this is at the intersection of Platt and Huron Parkway. This is one of our older fire stations. It's really exceeded its building lifespan. It was built prior to females in the fire service, so it doesn't have a very good separation for kind of gender equality in terms of showering and bathrooms and sleeping quarters. So we're addressing a lot of long-term issues with this, but related to this group is what we're super excited about, is that this would be the first net zero fire station in the state of Michigan. We estimate that it may be the first net zero east of the Mississippi. There's a couple in the western states. Salt Lake City's kind of taken the lead with this. There's not exactly a database of these, but doing some pretty extensive research, I'm not too aware of one east of the Mississippi. So we definitely know for state of Michigan, and we think east of Mississippi. We would achieve this through photovoltaic, and on the picture you can see the solar array would be on top of the station. There would be some parking on the south side, and we would actually extend the solar array above the parking spots, and then also with the parking spots we would have some EV chargers. The parking on, or I should say the truck in exit on the south side would underneath that would be the geothermal heating and cooling wells. And so those familiar with that requires kind of a lot of wells to be drilled down. And so that field would be on the south side of the station. Another kind of plus for this, not necessarily sustainability, the exit of the fire station would align with Platt and Huron Parkway. Right now it kind of exits in a blind corner, which is not ideal for emergency response. So we're super excited about this. Also been working very closely with Dr. Stults throughout this and trying to use it. I always mess up the term, so Dr. Stults, you can correct me, but building materials that are sustainable. And I know there's a much more eloquent term for that, so I'll turn that over to Dr. Stults. But anyway, thank you very, very much for the time, and we would glad to answer any questions, and again, really appreciate any potential community support for this. So thank you.
Thanks, Chief Kennedy. And embodied carbon is sort of what we're looking to manage on this particular site. One other project we just want to make sure that you know about in the sustainability space, if I can get this forward, is the deployment of a significant amount of solar on city facilities. This project, and hi everybody, my name is Missy Stults. I'm the Director of Sustainability and Innovations here at the city. This project's been in the works for a while. The city has a goal of powering all of its facilities with 100% renewable energy, and this would take us a really significant step towards that. So we've modeled solar where all of our roofs can handle it and aren't in need of replacement. We've got 19 city facilities. We've got full designs for those facilities. That includes every parks facility that's got a major piece of infrastructure in which we could put solar, or opportunities for carports. It includes the water treatment plant, the wastewater treatment plant, the public works building, city hall, pretty much the major facilities that you think of in the city. The estimated cost is $8.5 million for the project. And what's really exciting about this, not only does it very clearly align with our clean energy goals, local workforce development, but it also means significant operational savings. We estimate at least $500,000 a year in operational savings to the city, which can be reinvested in other priority areas. And that's for a 30-year period of time. So it's significant savings over a long period of time that we could invest in other sustainability projects, infrastructure projects, or other priorities that the city may have over time. We're really excited to see this project move because of its slew of co-benefits, and it's one of the projects up for consideration. And I just want to end by saying we're only sharing 2 of these projects with you. So I'm just going to quickly show you, if you'd like to learn, don't look at my crazy calendar. If you'd like to learn more, you can check out the city's ARPA website. And I think the team did a fabulous job. There's videos here on all of the projects. And as the Assistant City Administrator mentioned, on Friday, we'll be launching a public survey to get feedback. So you can quickly learn about all of the projects up for consideration and share your feedback with us. So I think, Zach, if we have a minute, maybe we can see if there's any burning questions.
So I do see one question in the Q&A box here. The costs for the 2 city projects were shared, but what are the savings? Dollars, CO2, other externalities?
Yeah, so I'll take it for the city facilities to say the cost savings are $500,000 a year minimum in operational savings. And then, of course, CO2 reduction, I can get you an actual figure if you want to send me a note, or I can post that on the site. I don't have it at my fingertips at the moment, but it's the equivalent, the size of these installs is the equivalent power production for about 450 to 500 Ann Arbor homes.
We have another question. Does solar work during the winter? What are the costs of clearing the panels?
Great question. So yeah, solar absolutely does work during the winter. We still have sun, and it's operationalizing and utilizing the sun to perform and create power. Some of these sites are going to be easy to clear, carports and things we might be able to come out and just through maintenance be able to wipe down. Others are not going to be as easy to clear. You can imagine on top of a roof, that's not very accessible. Some of them might be. So we expect performance to we've modeled performance based on Michigan winters, and we still expect to actually have really notable performance, but we will peak in summer for sure. And then winter performance will drop.
I got a question for Chief Kennedy. Chief Kennedy, thanks. Exciting fire station project. Will this building be completely independent of natural gas? In other words, no gas hookups?
So the plan is no natural gas. A real struggle we're working with is obviously being a fire station. It has to work 24/7. We're literally working with the engineering on the mechanical side as we speak with this. And Dr. Stults, I'll be happy to have her jump in on this. The estimated battery load, if we were to lose power, because obviously it has to work, we've got to be able to open the doors at night and charge batteries and those sorts of things. The battery bank, I think they estimated at like $2.5 to $3 million, which would almost be 50% additional cost to this. We realize that the technology is going to improve. And so right now we are currently looking at a generator that would likely be propane powered, with the idea that as battery technology improves and that cost comes down, we could remove that generator and that propane tank. That is not finalized yet. Again, we are working with mechanical, but this being a fire station, we do have a very real need for uninterrupted 24/7 service, and the batteries were a bit cost prohibitive, but we realize that technology is changing.
Thanks, Chief. 2 more questions. Probably for Dr. Stults. How much electricity is used by city facilities?
That number fluctuates, of course, and in the pandemic, it's lower in the last 2 years than it has been historically. If you want to take a look and get the specific number year over year, we post our greenhouse gas inventory, where we actually give you the real-time usage of electricity. The estimate is about 24 to, wow, I just totally dropped it. 24 megawatts is roughly our total demand over the course of the year. And again, that will fluctuate depending on usage. And as we electrify, that'll change as well.
Another one, is it expected that excess solar power during peak periods will be sold back to DTE, not metered, or will it be collected in batteries? Or is there another solution?
All of the above. All of the above, right? So every site is being designed to be battery ready. Certain sites we are, depending on what kind of allocation we get, we will be deploying batteries on site. Others, we will be adding batteries when the time becomes right, whether that's economics or the technology advances to a point that makes that viable. So both, all of the above.
And for Chief Kennedy, will the fire engines be electric vehicles?
Not initially. We are building the facility to take the chargers. Obviously, it being a big kind of commercial chassis vehicle, the chargers are an issue, and so it's being designed for the charger to be there. The electric fire truck technology is still evolving very, very rapidly. So at some point in the near future, there will be an electric fire truck there, and we're designing it for that. I don't know when the station opens if there'll be one in the bay, but we're certainly accounting for that as a future reality.
Great. Any other questions? Give that a second for a question to stream in if there is one. I'll just let people know that the community engagement survey that we'll be publishing will be available through A2 Open City Hall. If you go to Google and just type in A2 Open City Hall, it'll take you right to our website, and you can sign up for notifications from the city there. And anytime we publish a survey on any topic, you'll get an email notification saying, hey, we're asking for your opinion on this thing, so go ahead and fill it out. And so if you want to sign up for it, you'll get notification of the ARPA survey as well, and you can tell the city how you feel about these and other projects that we might be funding. So I don't see any other questions. I think that concludes our ARPA discussion. And unless there's anything else, I'll hand it back over to Zach.
Awesome. Thank you, John Fornier and Missy Stults and Marty, Prashan, and Chief Kennedy. It's really important that we get these updates and hear from everybody, just given the fact well, tonight we're talking about home electrification, but we are working towards electrification citywide. And so these dollars are being put to really good use in our community to help further that goal. And so we found it pretty poignant for tonight's conversation. So thanks everyone for tuning in and for the thoughtful questions. At this point, I think we'll transition back into the home electrification focus. And so as I teased you earlier with the introductions of our panelists, we're going to go back to Hank from Elevate Energy to give us a little bit of background about some electrification and grid in terms of building envelope stuff. So Hank.
All right, thank you, Zach. Some people have a voice for radio. I think you might have a voice for podcasts. I want you to tell me a true crime story.
Oh my goodness. I'll read you a bedtime story anytime.
I appreciate that. All right, everybody. So I've been asked to share kind of what you need to do to be electrification ready and what that actually means from kind of an infrastructure perspective, and also a little bit about your home before we get into like the specific systems of your home. So everybody can see the presentation? Wonderful. All right, so there's a couple different things that need to be in place for your home to be fully electrified. And that's start one with capacity. And that is, what is the capacity of the local circuit your home is on the overall grid? The substation that you're connected to, how much capacity is on the neighborhood transformer, the big box on the pole near your home, what level of service is coming to your home, how big your electric panel is, And I'll talk about some things in terms of renewable energy and storage ready, energy storage ready, and what that means. Your breaker capacity and how big the panel is and what different breakers can handle. And then we'll just talk quickly about some building envelope, your building shell, how tightened up your home is. Does it leak like a sieve, or is it basically a giant cooler that's airtight? That matters a lot for electrification and the potential costs. So that's your doors, windows, insulation, air sealing, ventilation, and your HVAC distribution system. So when energy gets distributed to your home, it's coming from this big transmission grid. That's the big power lines, the big towers that run across the state. That gets stepped down at your transformer, or the substation, to a lower voltage so that it can be fed to your home. And as it gets towards your home, it can be stepped down even further once it gets to the neighborhood level. It's at the poles, and it is run to your home with a certain amount of amps that your home can pull at any time. If anybody's thinking back to physics right now, amps and volts and kilowatts and all that stuff. But the total amount of power your whole home can use at any time is determined by the amount of service you have to your home. A lot of homes built before the 80s in Ann Arbor have 100 amp service because most of them had natural gas for their heating and their water heating and their cooking. And it was lights and plugs for everything else on the electric circuit. So more modern homes built past the 80s have 200 amp service, which allows them to pull a lot more energy at any given time. And much larger homes typically have like 400 amp service. So once that gets into your home, if you ever want to find out what amp service you have to your home, there's a big main electric switch at the top of your electric panel, and that should have the number that indicates your amp service to your home. On your electric panel, you'll see a series of different circuits that have different amperages for each circuit, call them breakers. And then some of them have different voltages. Some are 120 volt, some are 240 volt. So 120 volt is like the plug on your wall. 240 volt is like your air conditioner if you have a central AC, or if you have a big electric stove, or another large appliance that uses a lot of energy at one time. So the mix of those on your electric panel will determine what types of things you can hook up to your electric panel. And that really comes into play when you're trying to electrify your whole home. If you're trying to add electric heating and cooling, and an electric water heater, and an electric dryer, an electric stove, these are things that many of which could need a 240 volt circuit on your electric panel. You need room for that, but you also need to make sure that if you flipped on most of the stuff in your house, that you wouldn't exceed the total amperage that your service can provide, or your panel will just shut off. And like tripping a breaker in your house, your whole panel can shut off. So these are all important things to understand when you're trying to electrify your home. How much total power could you end up using at one time? Okay. Now, if you want to also have solar and a battery in your home, the common way to do that now is actually pretty complicated. You need a critical loads panel if you want energy storage in your home, which means you need to pick which things won't turn off if the power goes out. And more they're having automatic switches, but a lot of times you have to do a manual switch to switch over to the battery. It's a lot of innovation in the space. Nobody wants to have that system. Everybody wants it to work seamlessly. So there have been a lot of new technologies around like smart panels, which basically is an electric panel with a computer in it that can reconfigure what your electric loads are. You can change them on a phone app. and they seamlessly switch between using your solar power, your battery, and the grid. That's the ideal. But those are very new. They're not readily available in a lot of markets, and they're really expensive right now, unfortunately. But that cost is going to come down as it gets more adopted in the market. But they're super cool. It's just something that's kind of like on the cutting edge of what's possible with your home. All right. Your building envelope. So back to our physics classes in high school, heating and cooling in your home are affected by three major things: convection, conduction, and radiation. Your home breathes. Hot air rises and it escapes through cracks and places where air can escape through the top of your home, and that creates a pull of cold air coming in through the lower part of your home. And that's convection, hot air rising, the cold air coming in to take its place. The leakier your home is, the more that air gets sucked through it constantly. And so that can take all of your hot air and suck it right out of your house and lead to having really high heating costs. Tightening up your building shell through things like air sealing can help really tighten down that infiltration and make the airflow through your house much more controlled. There are things like insulation that actually, the heat travels through your home through walls and pockets of air in your house, and that is convection or conduction, pardon me. And also convection can be reduced with insulation. So putting insulation in your attic, putting a big layer of insulation to stop all that heat from escaping, or around the rim joist in your home to stop the cold air from coming in through the bottom of your home, or insulating your walls, can all help reduce your conduction. And then there's radiation. The sun heats our homes depending on where your windows are, your position with the sun, whether your home has dark paint or a dark roof. You absorb the radiation from the sun, and that can get into your home. So there are a lot of different, you can have a lighter roof as a simple way to reduce some of that. Or you can get really fancy windows with triple pane and low E glass that actually reflects a lot of the radiation, so you can lower that heat gain. You can also use things like window shades, awnings, and things like that to reduce the radiation in your home. So here's an image of conduction, radiation, convection that I thought was useful, and how that the heat travels through your home. But also a thermal image of a home where it's obvious that the heat is just escaping through the attic pretty heavily. So all that heat is going through that house and going right out the roof. So it's really important to think about all the ways that your home can reduce that air infiltration and convection, conduction, and radiation to make sure you have a lot of control over heating and cooling in your home. The more efficient your home, your building shell is, the lower your overall costs for heating and cooling your home will be, and the more control you have. You can have smaller heating systems and cooling systems. You don't have to oversize them, and that can lower the upfront costs as well. However, if you do that, if you turn your home basically into an airtight shell, that can be a problem if you don't have air exchange. You need fresh air in your home. So if you do tighten up the building, you need fresh air to be exchanged constantly. So you need ventilation systems to make that happen. And so having really effective ventilation can ensure that you don't have a problem if you decide to really insulate or seal your home. Okay, so also if you're thinking about electrifying your home, you're going to have to think about your current heating and cooling system. You can do whatever you want, but there are implications on what that might cost you. Older or more traditional types of heating and cooling are your forced air system, ducts, steam radiators, big, curly Q things, radiant heating, having water pipes run through your floors and walls to circulate heat and also can cool your home, or running hot water through baseboards, or having electric baseboards. If you want to change your heating system, this infrastructure may be run through your entire house and you might make it obsolete, or you might be able to utilize it for an all-electric system. Something that's very common now, which we'll probably talk about later, is getting something like a heat pump. You can use a heat pump on an existing forced air heat system. You can run it through your ducts if you want. But if you don't want to do that, you can do what's called a mini split system, where you have individual units that run into different parts of your house. You can have multiple units, outdoor heat pumps that run. I put a couple different examples of how they can be run into rooms. These cassettes or floor-mounted units, a concealed ceiling unit, or a wall-mounted unit that are run through your wall, and there's no ducting system. All the heating and cooling comes directly out of that kind of embedded system that's put into the rooms. You can heat and cool multiple zones of your home. So if, like me, you live in a traditional colonial style home, all of my heating and cooling systems run right through the middle of my house in the load-bearing wall. So if I wanted to open up my wall and put a nice pass-through or something like that, all my ducts are there. So if I have a gas furnace now that I'd love to replace. So if I wanted to get rid of my gas furnace, I could also get rid of my ducts and open up my wall and see the outdoors from my kitchen if I really wanted to. So you have options, but all of these things come with costs potentially. So it's a key consideration when you're looking at options to electrify your home. And I blew through that pretty quickly, so I'd love it if anybody has questions. I'd be happy to answer. And just Zach, stop me if I'm going to get into anything that might be covered in a following session.
Certainly. Folks, you should have access to a Q&A at the bottom of your screen. So feel free to submit questions via that, or you can raise your hand and we can unmute you and give you permission to speak if you would prefer to do it that way. Well, thank you, Hank, for giving that background on sort of how the energy transmits to the house and the considerations in terms of the building envelope, and giving folks a bit better picture of the different things to consider when you are electrifying your home in terms of ventilation and whatnot, because that's super key. So thank you for that info. Yeah, you see that?
Yeah, so Jonathan, it is possible to add a heat pump to your forced air system without removing the gas furnace. In some cases, it could be a nice bridge to going fully electric, having your furnace for gas backup through the end of its life. Like, my gas furnace will probably last a while because I had to have it fixed, but my air conditioner is probably going to go pretty soon. So if I want to replace my air conditioner with a heat pump, I can switch to using that primarily for all my heating and cooling and just keep my gas furnace as a backup for when it gets super cold and the heat pump's performance might go down a bit. And then when my furnace goes, I can decide to just not replace it and utilize just the heat pump.
So Hank, kind of a follow-up question to that just got submitted is, if you don't use forced air ducts with a heat pump, what are your options?
Yeah, Missy would like to answer this question live if she wants to. But I did mention the mini split systems do not require ducts. Missy?
No, I'm just managing the questions for you.
Oh, okay. Yeah, so there are definitely options. It all depends on the configuration of your house and where you would need to put the heating and cooling. So if you have an existing forced air system, hopefully it was designed to optimize airflow in your house, so it may be a more cost-effective option. But if your home has the ability to switch to a mini split system, those systems are more efficient because of the way that they distribute heat. Because a forced air system, you're actually like getting heat loss or cooling loss through the ducts as the air's moving through the house. So it's not the most efficient. With the mini split, you're sending all the heating and cooling to the very point where the heating and cooling enters your home and your room. But it just depends. Your HVAC technicians will hopefully, Matt will talk more to this, know the best solution for you and try to optimize for your situation and not talk you out of electrifying your home.
We've got a question here about, could you share the benefits for switching from gas forced air to electric?
Which considerations?
Well, I thought I understood it before I read it, but the benefits for switching from gas forced air to electric. So,
yeah. So if depending on what solution you go with, potentially one can remove an indoor system with your forced air furnace that you will not need that space anymore for it. You'll have an outdoor system with the heat pump. That's a minor thing, but it's really just the difference between having a traditional forced air furnace and a heat pump. It heats your home differently. It's very efficient. It heats it more slowly and gradually. So it's a different experience, but it's much more energy efficient. There is some issues with the cost to heat with gas versus electric. And that's a market issue, and it shouldn't be that way, but unfortunately that's the way it is, that gas systems cost less right now. Julie, you have your hand raised.
Yeah, I just wanted to add into their health benefits to an all electric home. Burning gas in our homes there's been some really compelling research out right now. RMI is at the leading edge of compiling this about very significant health impacts of burning gas in our buildings, including increased rates of asthma, even learning deficits in children, and cardiovascular deficits. And so moving away from gas burning combustion in our homes is a good health measure, as well as safety, because you're not going to have the potential of gas leaks and carbon dioxide leaks and explosions, which actually happens more than you'd think, and things like that. In addition to what Hank was mentioning about comfort, it's a premium product. It does come with a premium price. That is true. They are more expensive. They're also less volume right now, right? And so we know that gas furnaces are ubiquitous and they're everywhere, and therefore they're less expensive. But as adoption increases, I anticipate heat pumps will come down in price as well. But the comfort level, if you talk to people who have like cold climate heat pumps that work all season round, as Hank was saying, that it's a very even heat. It doesn't go up and down. It tends to be just very comfortable. The humidity is well controlled, things like that. And then of course, climate change, small thing.
Julie, sorry, yeah, really quick. Thanks for chiming in, Julie. I didn't introduce you earlier. Would you mind introducing yourself so that folks know who you are?
Sure, I'm just some random person that has opinions that popped onto the Zoom with
Aren't we all?
Right, all right. I'm Julie Roth. I apologize. I'm the senior energy analyst at the Office of Sustainability. I'm working a lot with the OSI and A2ZERO on building electrification, as well as residential solar and all things related to those things. So thank you, Zach.
Absolutely. Thank you, Julie. Hank, I didn't mean to cut you off there.
Oh, no, I had a couple answers for the other questions, but I'm glad we introduced Julie, because she needs no introduction, but we should definitely give her an introduction.
Yeah, absolutely.
So there's are there any systems that you described that get tax credits or refunds from DTE or others? DTE does not have incentives for fuel switching. So if you want to move from gas to electric, it's actually at the state level, utilities are prevented from providing incentives for fuel switching, which is unfortunate. We need state level legislation to fix that. In Illinois, they just did that with the Clean and Equitable Jobs Act. Now the gas companies can actually give you incentives to fuel switch to electric, which they're starting to do right now, which is exciting. And then from another incentive system like tax credits, there is something in the infrastructure bill that would provide an electrification tax credit. And as opposed to the way lots of the tax credits work now, it would be a full refund. You just get it, the money. You don't have to have a tax equity to be able to apply for it like you do with solar. So hopefully that makes it through in some form, because that will help buy down the cost of these systems to electrify homes. Someone also asked about the mini split. That's cool. Is there a hydronic version of the heating system? The answer is yes. There is what is called an air to water heat pump. And these are super cool because they are your heating, your cooling, and your water heating all in one system. And so they work just like other heat pumps, but they work really well with hydronic heating systems, and also do your water heating. So there's only a couple of those on the market right now, and they work best in new construction or if you already have a hydronic heating system.
I'm really excited by the number of questions that are coming in right now. There are a number that are asking about costs. And as much as we want to be able to answer those questions, and we will, I want to wait until after Mac's presentation, because he's going to touch a lot on financing options that are available through Michigan Saves. I'm hoping he is, and if he's not, we can fill in the gaps. So we'll just hold on those questions for a moment. So I just want you all to know, for those who are submitting those questions, we'll get to those, but I want to see what Matt covers first. There is one question that asked, is it true that heat pumps don't work below a certain temperature? And I just want to address that it's not what you think it is anymore. Heat pumps made a breakout a couple decades ago, and they didn't quite cut it at that time. But there have been a couple decades worth of technology advancements when it comes to heat pumps, and you would be surprised at how well they work, especially in our climate zone right now. It's the fact that, or the myth that heat pumps cannot keep up with our climate is simply that at this point. It's a myth, and they are getting better and better each year. And there are even backup options for those who are concerned about the possible cold spells that get below where the normal operating temperature of these heat pumps exist. And so there are certain electric resistance backup options that can kick in when it's too cold for the heat pump. But you would be surprised. They work in just about any temperature these days. They can work down to some very cold temperatures. I believe -5 is where most of them are being rated these days.
They have some that go down to -20 now as well.
Yeah, and there's been a lot of advancement. So if you knew about heat pumps many years back, you can pretty much discard what you learned at that time, because they're a whole new machine now. It's a different animal.
Those temperatures that we get, are right now, and don't last that long out of the total of the year. So you might have to use a backup system for a couple weeks out of the year, which really isn't much out of the whole big picture.
The city has compiled a lot of resources about cold climate heat pumps. In one of the Q&A questions, I put a link to the web page. You can actually go to a2gov.org/electrify, and then scroll down to the bottom of that page and click on heat pumps. And then there's a whole slew of information about cold climate heat pumps, including at the bottom of the page, some links to really good resources, a playlist of videos from Green Home Institute about cold climate heat pumps. There's NYSERDA and other really good owner sort of or resident facing manuals or buyer's guides, things like that. So a lot of good information there.
And there is still also some information coming out through some research that's being done, namely at the University of Michigan, but there are a lot of people who have eyes on this right now. And so they are researching the best ways to make a heat pump effective, including what that backup system would look like for different homes, and where they're necessary, and making sure that they are appropriately sized. So there is a lot of information, and thanks, Julie, for sharing some of those resources. I think at this point, maybe we can do one more question if there's one that's burning. And
I'll make a quick point on the
go for it.
questions here. One, the federal government just launched a national heat pump collaborative to try and get a national effort around cold climate heat pumps and getting them more market ready. Somebody asked, is a heat pump the same as a geothermal system? And this is a good question. So we're talking a lot about air source heat pumps, which sit above ground outside your house on a pad, much like your air conditioner does. A geothermal system is called a ground source heat pump. So it's the same type of technology, except they're pumping the air from a well dug deep in the ground where the temperature is more consistent to heat and cool your home. So that's the primary difference between the two: ground source versus air source.
Yeah, and thanks for taking that step back. And on that note, maybe we can take one more step back. And for those who don't have any idea what a heat pump is, you all have one in your homes, presuming that you have a refrigerator. That is a heat pump. And what a heat pump is doing is literally just extracting any heat that exists in a particular area and makes it colder in there. And so there actually isn't technically anything, there isn't technically such thing as cold, just absence of heat. And so when your freezer is really cold inside, what's happening there is that the components on your refrigerator are just extracting what heat is in there. So if you have your refrigerator set at 5 degrees or 0 degrees, yes, there's still heat at 1 or 2 degrees, and it is going to pull that heat out. And so that's how heat pump just works for your house. I see that there is someone with a hand up. So maybe let's hear a question, and then let's switch to Mac, and we'll hear a presentation, see what you have to share. So Linda, I'm going to give you the opportunity to talk now, so you can go ahead and unmute yourself. Thanks for your patience with your hand. I see, Linda, that you're still muted. If you still have a question, you can unmute yourself. Okay, maybe we're having some technical difficulties, but Linda, hang on to that question.
Address Chris Minke really quick, who happens to live like 4 houses down from me, about community geothermal
Yeah, sure.
wells, and let's start digging. But it is possible to dig shared geothermal wells, but there's some complications in how you do that between properties. It's technically possible. It's just complicated on building a shared geothermal well. Might be more possible at the property line, so with your neighbors or something.
Gotta be really good friends with your neighbors. Across that property line. Okay, well, cool. Thank you so much, Hank. We do recognize there are a lot of questions that have been submitted, and we'll open up the floor for a longer Q&A once we hear from Mac. So we'll circle back to some of these unanswered questions. But for now, Mac with Michigan Saves, I'd like to give you the floor for a little bit.
Hey, thanks, Zach. Really appreciate that. Yeah, like Zach said, I'm Mac McCabe with Michigan Saves, and we are the nation's first nonprofit green bank. I'm going to share my screen right here, and just going to go to. No, hold on a sec. Anyway, I'll prop up our website, but basically what we do is we're a nonprofit that's dedicated to energy efficiency and renewables, and we do that through financing. We go to local credit unions and we say, give us your best rates. And in exchange for that, we pay for any of the loans, a certain percentage of the loans that default that are written through Michigan Saves. And so we provide the best rates, lowest rates, they're below market rates, and also the lowest credit requirements. So we're bringing more people into energy efficiency. And what we've done over the past, 10 or so years is we've amassed a large contractor base. And we've got about 800 contractors in the state of Michigan that are authorized for Michigan Saves. And what that means is that we make sure they're licensed, we make sure they're insured, we provide third party, which we do, quality assurance, and we make sure that they have all of the requirements or certifications that they need to do the job that they do. So we have a really good contractor base. And how we got into the electrification side of things is electrification's not cheap, and a lot, with a really good low interest rate, you can make it make sense, and it helps out contractors selling, it helps out customers with a monthly, spreading it over the life of the equipment, where you can have a manageable monthly payment. So with these 800 or so contractors, when you go out and ask people like, what is electrification? Not everybody knows, all that much. And a lot of contractors, don't really know all that much about it, but they're really good at what they do. So what we did is we came up with a training program that it really educates contractors on what electrification is, what are the other trades that are involved, how you can work together. A lot of the, the stuff that Henry went through and Zach was chiming in on and Julie, those are all things that are included in our training. How does a heat pump work at -5, right? What's the best switchover temperature from, going from your heat pump heat to electric, or, using a hybrid system where your furnace is your backup and you do it when your air conditioner switches. All those things are part of the training that we put together. It explains a lot about what a hot water or a water heater heat pump is, a dryer heat pump, how they operate. And so it's a series of 5 tests that we put together. And this was all in conjunction with Ann Arbor, and Julie and Hannah and Missy were all involved in putting this together. And they've just been a great partner with Michigan Saves. And what that is so the contractors go ahead and they watch all 5 of these videos. It's a little bit over an hour. They take tests on them. If they pass the test, then we give them a contractor badge. And what that means is that they're well versed in what electrification is, right? They know about solar, they know about battery backups, they know the contractors that do solar. So, the heat pump guys can refer the solar contractors. And another reason that we put this together was to also dispel the myths, that a lot of these questions that came up, like, does it work, below temperatures? What's the difference between geothermal and an air source heat pump? All of those things are questions that a lot of contractors, that are in the business also have, these myths or misconceptions. So they pass the test, they get the badge, and on our contractor locator is where we have a badge. So if a homeowner is looking for anything to do with electrification, they can go right to our site and go through our locator. I'm going to try to share my screen to see how I can get to my contractor locator. The screen is not showing the one that I'm looking for. I guess I should have tried that before we did this. I apologize about that. It's not showing me the screen that I need to get to the locator. But It's right on our website at michigansaves.org, and it has a find a contractor button. You click that, you select electrification, and all of the contractors will come up. We've got about 13, I think, contractors right now. We just launched this, so it's all really new. And you can search, by your location and what they do, but also through electrification. So one of the things that we hope, there you go.
That's
Zach, are you
yep, that's
controlling
me.
that?
Yep.
Yeah, so go to the find your contractor button. Right there. And then scroll down and it'll show your, so select, just go ahead and select residential, and then you don't really need a location, and then select electrification. So you can see we've got energy audits and air source heat pumps. You can search a lot through the Michigan Saves contractor locator. But if you scroll down, each one of these have a badge, and these are contractors that you can trust, that know about electrification, and that they also know about the other contractors that have done that. So, we're trying to kind of marry them together, along with anybody who's interested, as a homeowner. So, the contractors really appreciate the leads that are coming from this. And, we obviously want to advance electrification because it's in our mission, and everybody kind of wins through this electrification program. And that's pretty much it as far as whatever our electrification program is. When you're talking about financing through Michigan Saves, like I said, these are not cheap projects, and we will finance anything that has to do with electrification. So if it's a panel upgrade, anything to do with the heat pump, if you need to run new ductwork, whatever the case may be, the energy audit is, we cover energy audits, we cover, electric or the panel upgrades, air source heat pumps, anything like that. And if you have any questions at all, I'll field any questions, but that's what Michigan Saves is doing right now in conjunction with Arbor and what we're doing with electrification.
Great, thanks, Mac. And so when you see this electrification badge and you want to find out more information about heat pumps, for instance, or something along those lines, you can contact one of these contractors and ask them if that's what they do, right? And
it shows right in the second column. It shows what they do, what they're authorized to do through Michigan Saves.
Mm-hmm.
Yep.
And you can have them come out and give you a quote on doing some of this work.
Absolutely.
That's excellent. And then there's also a way for Michigan Saves to, or through the website, to connect to financial resources.
Yeah, so Michigan Saves is a contractor-based program where your contractor is the one that is going to guide you along the way through the process of Michigan Saves. They'll have all the rates that we provide, all of our rate sheets. They'll have the application and everything to do to get you into that Michigan Saves loan. But as a homeowner, if you want to go to our site and peruse through it, you can go to the residential homes, and through this tab, you can scroll down and go through, what we're about, all of our lending rates, how our process works. You can even apply for financing right there. You will need your contractor ID in order to apply because it is a contractor-based program, but you can go through and see all the rates that are available to you. And they're low rates too. I mean, with good credit, it starts out at 3.99. We do up to 15 years for these types of projects. For solar, we actually go up to 25 years. And we have some really fantastic caps. So our standard program is about $50,000, but when you get into solar, we'll go up to $100,000 These are all relatively new programs for us, but really anything that you have, that's regarding electrification, we have a product that we can fit in and to your need, whether it's 10 years or 15 years, or if it's solar up to 25. So thank you. I appreciate it.
Yeah, well, thank you. And we've got some questions coming in. So if you don't mind, let's see, I've got one here. Someone asking how one might be able to access the Michigan Saves training videos.
Well, you can go right to our website if you want to pull that up again, Zach. Sorry about the
sure.
the thing. I'll show you exactly where they're at. So if you go onto our website and you go to the contractor center, yeah, so select the contractor center, and then it'll come up. The next one will be a training options. So if you scroll down a hair there, that one right there. So that center panel, yeah, right there. So view the training resources, click that, and then it'll take you, go down a hair there. Right there. So the residential program, it says get started with residential electrification. And this will take you to all of, all of the modules that we have. So we have an electrification module that, go ahead and click that too, Zach, that electrification.
Oh, yeah. Okay.
Yeah. So this is the beginning of the module. This kind of ties together everything, right? How does solar and energy efficiency and air sealing and, hot water heating, how does that all tie into electrification? And that's the first module. Our second module, do heat pumps work in cold climates? This is a fascinating multi-year study that was done in Minnesota, which is a colder climate than us. And it goes through and it shows you, this is how a cold climate heat pump operated. This is how a furnace operated with a cold climate heat pump, or the cold climate heat pump with a furnace backup. This is how, just a straight up electric resistance system worked. And no, spoiler alert, it basically comes out that you save anywhere from $400 to $600 a year if you're using propane as your fuel source. And, it depends on what that mix was. But we also have a sales and value proposition, which is something that we really geared towards the sales crew that's going out. And then we have water heating, geothermal, and some contractor resources. And that kind of rounds out the entire training. And you guys are more than welcome to go through it and take the tests. I mean, you're not going to get a badge for our contractor locator, but I'll send you the badge if you do pass it. But it's some good information just about all the issues and myths that are out there right now.
Excellent. Mac, we have a question. Are there any options to finance, presumably through Michigan Saves, DIY electrification projects if they wanted to install things themselves instead of through a contractor?
Yeah, in certain cases you can. So if you wanted to, so if you were going through a supply house, let's just say we can make the supply house, because like I said, we're a contractor-based program, we can make the supply house the contract. If you're going to go to Home Depot, grab a water heater and put it in, can't really help you there. But if you're getting it through a supply house, we can finance that type of equipment. Now, if you're doing a do-it-yourself insulation project or something that doesn't require a license, then we can finance that as well. It's kind of like the honor system. You got to tell us how much the material costs. But yeah, there are options. So please, get in touch with us, and we'll kind of walk you through how that process works.
Do we have any contractors for new construction through Michigan Saves?
We do, but new construction's a little, we do some new construction, but typically they have other sources for funding. We're competing with bridge loans or, loans that are collateralized, because I don't know if I told everybody this, but all of the Michigan Saves loans are collateral free, right? It just goes by your credit score and, your debt to income ratio. and there's no collateral with any of our loans. But when you get into mortgages and bridge loans, they are collateralized, which makes them cheaper than ours.
Great. And because you get the financing through the contractor for the work that they are doing, if a homeowner is looking at doing an addition on their house that will involve some of these technologies, but isn't going to be the only thing being done, is that something that you'd still finance, or does that need to be dedicated to one or more of these technologies?
Well, it's got to be separated. Give us a call. We'll go through and tell you what it is, but there's not too many things we don't cover, and we have an allowance for things that aren't energy efficient. So, if you're putting on a roof, we cover roofing, we cover the cost of insulation, we cover windows, we cover doors, we cover heating, cooling. We cover anything that has to do with waterproofing, or, if you're doing, any type of electrical work that has to do with the furnace or LED lighting, like pretty much all your electrical systems. So yes, there are things that we cover a lot of the components in a new build. There's certain things that we don't do. I mean, we're not going to cover your framing and flooring and the wood that was put in there. But if you could show us that this is a method to energy efficiency, we would cover it. If you're saying, hey, I've got this new stud that is more energy efficient because it breaks the thermal barrier so that there's no, conduction, like Henry was saying earlier, then, that's an energy efficient stud. We would look at financing that because we're trying to advance energy efficiency and renewables. And, we have a set of things that we cover, but we're completely open to new ideas and new ways to do it. So give me a call.
Great. Okay. Cool. Well, I think for now, we'll hold off on questions again. And I want to shift gears to the electrification worksheet that you should have all received in your email. So thank you, Mac, for that helpful information about Michigan Saves and how people can find contractors to help them do the work and the financing to pay for the work. Because that's so critical, I think, for so many of us that some of this work can be expensive. So, and finding someone that knows how to do it and being able to pay for it is really critical to everyone, I think, achieving the electrification goals. So thank you so much for being here tonight. Okay, so at this point, I want to talk a little bit about the Electrify worksheet. It's the home energy sheet that we sent around via email. And if you registered for this, you should have received it in your email. And I'll share what that looks like right now. And there are some questions in the chat regarding where to begin. And this worksheet is one step in that big question of where do we begin on improving the energy efficiency of our home as a complete energy system. So this worksheet is something that you can use in conjunction with the information that we just learned from both Hank and Mac about Michigan Saves and the contractors that are available to you. And also now that you have an understanding of the system of the house and the information that Hank shared. And this, you can use this worksheet to help you prepare for electrification, because we don't want you to be in a situation, none of us want to be in a situation where our water heater goes out and now it's an emergency and we haven't done any homework and we don't know what kind of water heater we need. We haven't contacted a contractor about maybe thinking about a heat pump water heater. And so this is something that you can use for each of the appliances in your homes in consideration of preparing for electrification. And so you can use this to identify what kind of water heater you have. You can either print this out or just run downstairs and save this on your computer and run into your basement or wherever your water heater is and take a look at it and identify whether it's a gas or electric. and see if you can identify the age on it. You can usually do that by doing a Google search of the serial number, which will be on a sticker on the outside of it. Oftentimes, if you are in the city of Ann Arbor, appliances like your water heater or your furnace will have a sticker of when they were approved by the city of Ann Arbor. These are appliances that require a permit to be replaced. And if a permit was pulled when it was replaced, there will have a sticker from a city of Ann Arbor inspector who signed off on it and a date. So that date will be relatively close to when that appliance was installed. Oftentimes, the contractor also will put a sticker on the appliance with their contact information if you have any service questions. And sometimes that sticker will also have a date installed on there. And so you can use this worksheet to find the age of each of your appliances. And at the bottom here, we have a helpful little table of the average ages for appliances for each of these that are either gas or electric. And that you can use that then as a tool to help you identify which appliance you need to be thinking about in terms of replacement and in its life cycle. So if you go down, I'm saying downstairs because my furnace and water heater are in my basement, but yours can be in a number of different places. But when you go look at your furnace and you see that it was installed 28 years ago or so, and that the average gas furnace lifetime is 20 years, that's a really good indicator to me that I need to be replacing my furnace really soon. And it might be a good idea to do it before I have an emergency. What we didn't get included on this table are air conditioners. And because air conditioners and heat pumps work so similarly to each other, oftentimes when your air conditioner goes out, that's a really good time to put in a heat pump, an air source heat pump. Installed, an air source heat pump looks a whole lot like an air conditioner, and it works a whole lot like an air conditioner. And that's the beauty of an air source heat pump. There is a little bit more upfront cost to get them installed, but once they're in place, they work both to cool and heat your home. And so you want to also be thinking about the age of your air conditioner and when that can be replaced. There are also heat pump dryers that are available on the market. So even if you have a gas or electric dryer, there are heat pump clothes dryers that are far more efficient than even the most efficient electric clothes dryers. With a lot of these things, when it comes to replacement in terms of using heat pumps, there is a little bit of a behavior change. And so we'll discuss that here in a moment, but I just want to make sure that you have this tool available to you, and then you can use this information. You can also write in the margins or somewhere on this sheet which contractor you would like to use. And you can use that contractor locator that Mac just introduced us to help you identify who you want to work with. And you can get quotes even ahead of time before you're ready to do the work, so that when it comes time to pull the trigger, you've done the homework and you're ready to go. A couple of considerations when using heat pumps just to consider are certain behavior changes. They work differently than the equipment that we are so used to using, many of us, when it comes to, say, a gas furnace. The capacity for a gas furnace to produce heat is much greater than the capacity for a heat pump in an instantaneous moment. And so what that translates to in terms of behavior and use is that we are used to these cycles of letting our house cool down, and then the heat kicks on, it heats it up, and then it cools down. And so it makes sense when, say, you're going to work for the day, pre-pandemic when we used to go to work. There are a lot of us going back into work, and thank you all for that. But we used to all go into work, I think, and it was normal to kind of turn the heat down so that it wasn't heating throughout the day. The way that might compare to a heat pump, for instance, is that a heat pump has a lower threshold for range. And so you want to keep it in a similar range, and that's actually more efficient to keep it working to maintain the same temperature than it is for these large swings that we're used to with a gas furnace. Something like with a clothes dryer heat pump or heat pump clothes dryer is that it can take a little bit longer for it to dry your clothes. Now, for the most part, that's not a big deal. A lot of us leave the dryer just to run on its own. And when the clothes are done, then we just leave them there for a little while until we can get to it. And so in consumer studies of folks with standard dryers and heat pump dryers, they actually didn't notice a big difference. But it's something that you want to consider upfront if you are somebody who's trying to push through a lot of loads really quickly. That's a consideration. When it comes to like a heat pump water heater, for instance, that it does pull the heat out of the immediate vicinity. So whatever room your water heater is in will have cooler air in it because it is pulling the heat out of the air and putting it into your water heater. And so that's usually not a problem, but it's a consideration depending on your water heater location and whatnot. Now that we've introduced that tool, I saw a couple of questions about the whole house as a system, and the fact that there's a lot to consider. And so how do we get advice on this? And so one thing, a mentality that the Office of Sustainability has really adopted and that we're hoping to promote is to not think of electrification or home efficiency necessarily as a step-by-step list, but more as a choose your own pathway. There are a lot of things that you can do, and in some cases there are certain processes, but really you can start anywhere. You can do your replace your gas stove with a electric or induction stove at any time, and you can replace your water heater with a heat pump water heater at any time. The one process that you might want to consider was mentioned by Hank when talking about the envelope. And in order to get a heat pump that is right sized for your house and will work most efficiently, you want to make sure that that envelope is well sealed and well insulated. And so that is one step where it would help to have your house sealed, and to contact a Michigan Saves contractor who does air sealing and weatherization, and they can help you seal your house, and then you can get the right sized heat pump so it'll maintain its efficiency for your home. I think I will invite both Mac and Hank back, and maybe we can look at some more of these questions if you guys are both available.
I've been trying to answer lots and lots of them in the, I've been typing furiously too, so, but I've left a bunch up as well.
Well, yeah, thanks.
I've answered a couple questions too. And yes, Julie, please join the conversation.
Yeah, and that's great. And we can even revisit some of those questions that you've been answering for the recording for the folks who are watching who won't be able to see the chat. So if there were some really good questions that you saw and you would like to bring light to that information, feel free to jump back to it.
One thing that was kind of interesting, somebody asked about an energy recovery ventilator. Now, that is a part of the ventilation system that does a heat transfer or cooling transfer with bringing cool or warm air into the house and transferring it to your heating and cooling system. So it's a way to build efficiency into your existing system through your ventilation system. But it's, you got to talk to your HVAC technician to make sure something like that is even possible or worth the investment for your home. But they can work really well, I believe, if you're trying to do zone heating in your home. But I'm not an HVAC technician, so talk to a professional about what's right for you. But it is definitely another piece of technology that could be interesting in electrifying your home.
Well, and now that we all know how to use that Michigan Saves contractor locator, bada bing,
You know where
bada
they're
boom.
at.
I see a question here about do heat pumps work with refrigerators and freezers? And believe it or not, refrigerators and freezers are heat pumps. And so that's the one fun thing that not a lot of folks realize is that we all, if you have a refrigerator, we all have a heat pump in our home, and it's working on the exact same principles. It's just smaller. It's contained to that box. And so if you can think about the equipment on the back of a refrigerator being the size of an air conditioner and sitting outside of your home, it's essentially the same thing.
One person was asking about, are there consultants or contractors or experts that can help you create an electrification plan for your home? Interesting thing about the industry that's out there, it's nobody's job to know how to electrify your home. It's actually at least three trades jobs to understand how to electrify your home. You need mechanical for your HVAC systems, electrical for your electric systems, and plumber to cap your gas line. If you're using a gas line, they're the pipe fitter. They will shut your gas off and cut you off from your gas. There is what's called an MEP firm, mechanical, electric, plumbing. Some businesses are all three trades in one business and might know how to do that, but a lot of those firms work in larger commercial settings, not residential. So the short answer is, unless they specifically have learned that there's demand for this and want to do it, and Mac's program might have some of those people.
Yes, we do.
It's actually nobody's actual job to know how to electrify your home. So Mac, if you want to add anything to that, please.
No, I just say that we do have contractors that have handshake agreements with other trades where they, the electrician who's putting in the panel makes sure that the heat pump, there's enough room there for the heat pump and the solar contractor, and they can talk to each other and work together on that. So I think, that this is exactly one of the things that we were trying to accomplish with a badged program, and hopefully it works. And if you get a hold of somebody who you don't, or if you're not finding the information that you're looking for from one of our contractors, call me, because we are dealing with all of these contractors and we might be able to point you in the right direction.
Contracting is a very social business. So
they all know each other.
They all know each other, and they'll know who to call if you have specific needs. And it's wonderful that Michigan Saves is doing this to make sure consumers can understand what a contractor is, understands about how to electrify your home. Because I've had my contractor, I will not name them, definitely try and talk me out of electrifying my home, and made a very compelling case for it, but I was still like, I think I'm gonna do it. So
stand your ground,
not with them, apparently.
There's a really good question here about taxes, and if they're a low-income family that we know is concerned that if they go through a substantial energy upgrade, that their taxes will go up and that they won't be able to afford the taxes, and wondering what kind of help is available for them.
Efficiency upgrades wouldn't normally affect the taxable value of your home. The costs for your utilities is more about the perceived value of your home. So if you were to sell it and say like, hey, it's super efficient and it's really well insulated and comfortable, you might be able to sell your house for a premium. But the way that your tax assessor values your home does not typically include those types of features. So
I'm going to jump
I
in
wouldn't expect-
and back Hank on that. I talked to the assessor about some projects. This is Missy, just earlier this week, and that's absolutely correct, that it wouldn't increase your taxable value.
There's also, there was a question I answered in the chat, but I wanted to elevate it. It was actually more of a contribution from Karen, who says, I think it'd be useful to have people share their experiences using heat pumps in different types of homes and how they manage with the 4 seasons. And I absolutely agree with you, Karen, and we're talking to people now and doing this exact thing. I think residents talking to other residents who have gone through some of this electrification work is really valuable. And so if there's anyone on this call who would like to contribute to such a project, please, by all means, give me a call, email me at the city. And I think I think it's a great potential project. So thank you for that.
Got a question. Is a heat pump water heater better than a tankless water heater? And I am going to translate better as efficient or more efficient.
That's a good question. I'm not entirely sure if it's an electric heat pump water heater should definitely be more efficient than a tankless electric water heater. The cost comparison between having an electric on-demand water heater, as they're called, versus a gas, the gas wins on efficiency every time. But I don't know about the difference between a gas on-demand water heater versus an electric air source water heater.
Well, I do.
Hey!
I'll answer that question. Is a heat pump water heater better than tankless? Yes, always. Even the gas tankless water heaters, the best COP, the coefficient of performance that you can get out of a tankless water heater is 1-to-1. And what that coefficient of performance means, that COP, is how many units of energy you put into it and how many units of energy you put out of it. So if the COP is 1, that means that it can only be directly translating the heat that's going into it and the heat that's coming out of it, gas or electric, if I'm not mistaken, on a tankless. The COP on a water heater can be up to 3, which means that for every 1 unit of electricity that you put into it, you're getting out 3 units of hot water. So there really isn't a comparison in terms of efficiency. Heat pumps far exceed any gas or electric options in most cases. So
thank you for busting out the COP on us, Zach. That's great. And that's one key component about heat pumps in general is the energy is not coming from, like in most of our systems that we use, we convert like gas to heat, we burn it, or we convert electricity to heat, we just zap it and release that electricity as heat. And a heat pump is pulling in the heat from the air around it and using that ambient energy that's out there to transfer it to our systems. So that's great.
Someone has asked if there's a website that explains the mini split system. And I'm wondering if any of you are able to explain that well enough in person, or if you know of a really good website.
Well, I don't know if I certainly know how a mini split works. It's really like any other heat pump that works, where it basically absorbs the heat from, or the cold, whichever way you're doing it, right? It absorbs it through a refrigerant, it transfers it, it compresses it, and releases it. So whether you're heating or cooling, that's the basic concept of any heat pump. But there are some fantastic sites out there. I know Mitsubishi has a really good site on their mini splits. They're probably one of the best manufacturers for the mini splits out there. Yeah, I mean, the thing the thing that really that made the transformation, I know, Zach, you were talking about how, heat pumps came out decades ago. Well, it was just recently where they started using this modulating compressor technology. And that is what really has moved the needle on heat pumps. And it really is exactly that. It's like a variable speed compressor that has made the cold climate heat pumps work a lot better. And they touch on that on Mitsubishi's website. And Bosch also has a good website that explains what a heat pump is, how it works, and how specifically their variable speed technology is better for for the consumer.
Thanks, Mac. Still a lot of questions coming in. Thank you, folks. Keep them coming. I also want to throw out again that if you want to raise your hand and just ask your question, you are welcome to do that. You can raise your hand and we'll give you permission to speak. Just giving you another option. So there was a question that came in, I believe this was during your presentation, Mac, asking if there are consultants, contractors, or other experts that you can hire to create an electrification plan that takes into account everything you talked about here and that is specific to your house. There's a lot to consider. So they're wondering how they can get an expert involved to give a specific direction. And I have thoughts on that, but I want to give either of you a chance to address that.
Well, contractor locator. I mean, we have a couple. I'm just going to drop some names here, but one of the companies that does everything. They do heating, they do cooling, they do energy efficiency, they do solar, and that's Oak Electric. They're located in Waterford, Michigan, and they can do that for you all in-house. With most, you don't see a lot of companies that do all of it, right? There's typically an HVAC company that does the heat pump, and a solar company for solar if that's part of your plan. It depends on what your electrification plan is, but that's the whole purpose of our contractor locator, and to train up all the contractors on what electrification actually is and what it means. So there are a couple companies out there. If you look at the second column of that locator that we were looking at, it'll show all of the things that they do. So if you see a company that does HVAC, plumbing, electrical, and solar, that would probably be your first pick if you want to get a plan to do it. But I don't know of anybody who's specifically doing electrification plans. I don't know anybody. That doesn't mean they're not out
there. Well, I would like to mention that we, in the Office of Sustainability, are exploring right now a program where we could offer that service, either in-house or using a third party that could help us provide those services to the community. It's still in its infancy and it's still being developed, and we're trying to figure out how we could best implement that. But I do just want to mention that it's something that we are aware of. We are very keen in the Office of Sustainability that is an issue, and that we want to be able to effectively connect people with the correct resources that are applicable to them. So we're hoping that we can provide that, and so stay tuned. Like I said, it's in its infancy. We're still developing it, but we want to be able to answer that question, because we know that's a huge hurdle for a lot of folks, is knowing where to begin, and that's one of the things that we're hoping to illustrate through this, is that you can get started really at any time. We kind of want to break down the barriers, these thought barriers, these perceptions that you have to have everything in all your ducks in a row. You have to do it all at the same time, some people think, or that there's just too much to do and it's not going to make a difference on your house, or that it's going to be too expensive. And it's easy to fall into that way of thinking, but truly, to make the changes in your home starts with one thing, and you can change out your water heater when it comes to the end of its life, and you can go step by step. And so that's why we provide you with that tool, which will also be available on our website, to help you identify what appliances are in your home and begin making that plan in a way that kind of makes sense. And once you can lay it out and see the life cycles of your existing appliances, you can begin to map out when you want to be prepared to replace certain appliances. So that's a really good question, and I'm glad that you asked it.
And I'd just like to flag on that, Elevate does this work, but we know our limitations, and like any company that can provide like an energy audit of your home, unless they are also a qualified HVAC technician, an electrician, a plumber, or a solar installer, they can give you a good idea, but you do need a qualified tradesperson to really tell you what's necessary to do these things. So it's important that somebody can give you an idea of what's possible, but make sure you talk to people who are qualified to understand what is absolutely realistic and necessary for you to be able to do these things.
Thank you, Hank. And we all know where we can find a qualified energy home auditor, right? Say it together, everyone. Michigan Saves Contractor Locator. Cool. Let's see. Were there any other questions that you all see? I need to get caught up here.
There was a question, and several ones that were answered, and then another one. So I think it's a question many people have, which is about backup heat and heat pumps. So just to clarify, there's two kinds of heat pumps. One would work as what's called a dual fuel system, which is a heat pump that works somewhere down to like around 30 degrees or so. So it works to air condition. We call it a heat pump, right? But it's really a bi-directional air conditioner. So you could get a heat pump that replaces your air conditioner and works in the summer and the shoulder seasons, sort of spring and fall, until it gets very, very cold. And then that switches to gas furnaces backup heat. If you want to completely cut your gas line, like me eventually, then you're looking at a cold climate heat pump, which doesn't use gas backup. And in that case, there is an electric resistance coil or strip that's an option for you. And what would happen is at very cold, like sub-zero temperatures, it could switch to electric resistance, which is not very efficient. It's like heating with a space heater, but it doesn't kick on very often because the cold climate heat pumps have gotten really, really good in technology. So it's either electric resistance backup or it's gas backup in a dual fuel system. I hope that answers that question.
And sort of in a similar vein, I see at least two questions, there might be three, asking about how heat pumps would be faring in the current weather that we are experiencing this week. And well, I guess, would any of you like to answer? What I do know is that the temperatures that we've experienced over the last week and in the coming week have not dropped below where a lot of these heat pumps are supposed to be able to operate. So there shouldn't be any issues. I don't have a heat pump, so I can't say that I haven't experienced it. If there is someone perhaps who's on the line who has a heat pump, I see some familiar names in there. I'm not going to call anyone out in particular, but if you do have a heat pump as your primary heating source, if you wouldn't mind sharing how it's held up over the last week, I think we'd love to hear it. Either way, if it has or has not, I think that could be really informational for our group. So feel free to just raise your hand and we can unmute you, or you can shoot it into the Q&A. But let's see, if in the meantime, we've got another Michigan Saves question here, which is, can you have multiple loans through the program open at the same time? For example, if you wanted to do some projects now and others later, if you have some systems near end of life, but others that are still too new to justify replacing, or just choosing different contractors for different jobs, can you do more than one loan?
Absolutely. And we encourage you to use this because we have, 6 or 7 different credit unions that you can choose from when you get a Michigan Saves loan. We recommend that you use the same credit union, and then you put the, you can put that loan, the multiple loans. You could have 4 or 5, as many as you want. Put your payment date on the same day, so it kind of feels like one loan. But you can, yeah, absolutely. You can do it in phases.
That's really good to know. That was a good question. I see that a hand came up. So Lauren, I'm going to give you permission here to speak. So feel free.
I hate to sound like a Debbie Downer, but we have maximum solar power on our roof that we're allowed to have. And we insulated and sealed and hired an architect to model the energy for our home before we installed we were waiting as long as possible to do the heat pump just because of the cost factor and improvements in technology, et cetera, et cetera. But then our air conditioner died and leaked all over the place, and so did our hot water heater. So that was the end of that. So we installed Mitsubishi Hyperheat air source heat pump and a Rheem ProTerra heat pump water heater, which I had to source and purchase myself and store because it was not available anyplace else except for one supplier in Detroit. And we had an HVAC contractor who put all that stuff in, but still it involved a lot of legwork on my part. And I feel like I could probably take your class, Mac, and maybe without even reviewing my notes.
Yeah.
Now, here's the really bad part that you're not going to like to hear. In spite of all of this, including maximum solar on the roof, 38 panels, our DTE bill last month was $500. So, yeah. So, okay, my husband's confessing he has a hot tub. He says we have a hot tub. He has a hot tub. And he's only allowed to use it this winter because of Omicron. So anyway, skip the hot tub, but it's a lot of legwork. And I think, frankly, that the idea, some people have mentioned it, of having somebody who is basically a general conductor of home energy and upgrades is absolutely necessary. There are very few people who are going to go through all the stuff that we did, who've read as much as I have, who've spent as much time as I have trying to figure it all out. So I want to say that is something that really is necessary. And the other part of it is of course, ground source, ground loop geothermal is the better way to go, but there are a lot of obstacles to that, even silly things like zoning that we've got to get rid of. And because the way to go is to have ground loop in public right of way so that individual homeowners or businesses can just connect to it, what I like to call power parity. So when you take out the old gas forced air furnace, you put in your new geothermal unit, and it really doesn't cost you much differently to do it. That's because this is just not a model. The one at a time model is far too costly, difficult, time consuming. And we really need to find a way to move in that direction for the next step. So
I mentioned this earlier, a shared geothermal well in neighborhoods could be cost effective, but it's a huge infrastructure issue. So if you could place it perhaps below the streets when you're tearing up a street anyway, put a giant geothermal well, or in the right of way, dig it out. But you got to have it's quite an undertaking and very expensive to do. But once it's there, it's there. It's a big well for everybody to use, potentially in perpetuity.
I've been banging pots to get that done in my neighborhood for years now, because we have a street that also needs to be replaced in our subdivision, well, 2 of them. And the whole subdivision already has buried utilities. So that's another complexity. It makes it much harder for individuals to put in geothermal ground loop because you can't put it in the utility easement without special permissions and all kinds of stuff. And of course, one of the people that would have to give that permission is DTE, and they're not exactly knocking on doors to make it happen. So.
Oh, well, thank you for sharing, Lauren. And also, I just want to give you a thumbs up for doing the work that you are doing. I really appreciate that you have put forth so much effort into that. And because it's not necessarily easy. And so I'm glad that you have done it. And I'm hoping at least that tonight we're able to be providing the resources to other folks to begin getting started on their own pathway. And on that note, I saw that there was a thumbs up for getting some electrification planning resources and expanding on that. So
Yes,
thank you.
That's really needed. Oh, the other thing is the average age of the average electrician is something like 55. And the electrician who worked in our house was like, hey, we got to have more electricians. And that's absolutely true. The other thing is if you're electrifying anything and you have an electrician in your house, don't let that electrician do just one thing. Like, we're not in a position to replace our range yet, but we did have the electrician who was here for all the heat pump stuff go ahead and put in electrical and get it connected to our panel and everything else so that we can simply replace that gas range. We've got the electrical in place to do it. So that's the other thing to keep in mind is your electrical service and what you're doing next to plan your electrical upgrades.
Lauren, quick clarification in the chat is from one of the participants. Is your hot tub outside with electric resistance heat is the question.
I had to ask my husband. He said yes. I suggested he should be having a fire under it, but he didn't go for that.
So that can definitely really increase those bills. So
Right.
For those who were startled by that,
Right.
keep that in mind.
But one thing that is important here is that the electric rates we pay. Somebody brought this up earlier. Is we have some of the highest electric rates in the country in Michigan, and that is unfortunate when we're looking at the decisions to try to electrify for our own personal reasons, climate reasons, whatever they may be. And I think there are some issues that need to be figured out in terms of the market structure and whether our utilities should be providing better rates for all electric customers so that it's not as much of a cost burden on people who are all electric. All electric homes are more predictable in how they use energy because they can predict exactly how they're going to use them based on weather, because the primary poles are going to be because of weather. Electric loads are also demand response capable. They can be smart technologies. They can shift when they're used. They can be turned off. If you're on as I mentioned earlier, the smart panels can seamlessly switch between what's being powered by solar or by batteries. And that can all play into how a utility can utilize your home as a resource to manage its own demand. And that deserves a better rate. So.
There was a question about how the monthly costs of electrifying our homes, what that impact would be like. Just so on that note, Hank, and this person is asking if there will be any assistance for changing to electric. And right now, there is a lot of encouragement to do that because you can do solar and you can get federal tax credits, which are different than tax rebates. They're better for doing solar. And then if you have rooftop solar, now you're not paying for electricity, which is great. Julie, did you want to chime in on that?
You said what I was going to say. And Michigan Saves will bundle these things as well, right, Mac? Like if you're doing, the idea is if you can invest in solar to help offset the electricity that when you're electrifying, then that solar pays itself off over time and can really substantially reduce the cost of electricity. I think, Mac, you figured out the kilowatts, the cents per kilowatt if you add in solar. Do you remember?
Yeah, so it was over the life of the product, over the life of the solar array, and it was, there was a lot of assumptions in that calculation, which you have to do in order to get to the calculation, but it switched it from 16 cents a kilowatt hour down to 8. So like I said, there's a lot of assumptions there, but the federal tax credit helps out with the solar, but there's also, because that's a renewable energy, geothermal is also considered a renewable energy. So your tax credits for your geothermal loop, pile those on with the solar and you've got some incentives right there. And, there's hopefully some more incentives coming down the road. We're just, we're hoping, but there's, we've heard whispers and rumors that there are some incentives coming. We don't know them yet, but right now, those are the federal incentives.
If anyone knows any senators that could vote on Build Back Better, by all means.
Since we're on the topic, we actually happen to have a question come in that before we were mentioning this, that it's worth noting that the potential benefits of electrifying before you install solar panels. And what this person is talking about is that DTE has a way of determining what your electric capacity is, and therefore will limit your solar panels on your roof to whatever your high usage is. And so thanks for mentioning that. That is one thing that if you are considering getting solar panels at some point, that this is where some process can come in, where you might want to electrify your home first, because that will establish a higher electric usage for your home, and thereby expanding the solar capacity that will be allowable by DTE on your rooftop. Thank you for mentioning that. That said, there was another question about that is surmising that as a first step, you could say replace your gas dryer with a heat pump dryer. And would this have any impact on future efforts to replace the gas furnace? And it would not. So yeah, you're welcome to do those out of step with each other, even though we're stepping in the same direction by doing either. But good question. Thanks for asking that.
There's two things about heat pump dryers that are important.
Yes.
You already mentioned the one about longer drying times.
Mm-hmm.
One, they are ductless. They do not require ventilation, which is actually really cool. You can put your dryer wherever you want. You can put it in your attic, in your basement. You can put it in the closet. Doesn't matter. You don't need ventilation for it, which is great. Two, they do expel the heat that would have gone out through a ventilation. They do expel some heat into the room. So in the winter, that's great. In the summer, not as much, but overall, it doesn't make a huge impact on your home. And I guess I have a third one, which is you've done studies on them. You have to empty the lint trap every time or your efficiency goes down. Do it every time if you get a heat pump dryer. That's the best practice, which if you're like me, you wait until you have like an entire sweater on your lint trap until you empty it. You got to empty it every time to make sure it maintains its efficiency.
Yeah, I think, was it you that we were throwing around the idea of putting the heat pump dryer, which puts out heat, next to your heat pump water heater, which absorbs heat, and timing when you take your hot showers.
Nobody's done a study on it. Nobody's done a study on it. I'd love to actually do that just to figure out if there's a shared efficiency gain in that. But the system's good. Like my dryer is right next to my water heater, so it would, in theory, it would create an efficiency gain.
Yeah. And since we're talking about heat pump appliances, there was a question here pointing out when we were weighing the benefits earlier of tankless versus heat pump water heaters, and they make a good point. And so I want to elevate that one of the benefits of tankless is that they theoretically don't ever run out of hot water. I say theoretically, they don't really run out. I mean, they can heat. There are times when the electric heating element can overwork itself and it will shut off temporarily. But when you're comparing it to a tanked water heater, for instance, yeah, it's fair to say that it doesn't ever run out. And that the other side of that is that heat pump water heaters are a little more expensive. And I don't mean to be elusive about the cost of any of these appliances. Heat pump appliances have made drastic improvements over the years. It's still a little bit expensive at this point. And that is a huge part of the reason we brought Mac in tonight to talk about Michigan Saves, because that's an invaluable resource when it comes to replacing some of these things, because they can get you these interest rates that you really can't find anywhere else, which is, we're really lucky in Michigan to have the resource of Michigan Saves available to us to make these appliances accessible.
Regarded as one of the best green banks in the nation. We cannot understate that. It really is a model that people look to on how to create a green bank. We are very lucky to have them.
Mac and Hank, do you guys know if, or Zach, if there is a difference in how long heat pump water heaters last, the lifespan compared to gas water heaters? If there's a case to be made there, I don't know that.
I don't know.
I see Hank furiously Googling right now. Is that what you're doing?
Yeah, I don't know that. I think they were about the same, but I'm not sure.
I'm seeing that it's similar, 8 to 12 years average lifespan. That's what you expect out of just about any water heater. Same thing with heat pumps. They last 15 to 20 years, typically, similar to a average furnace in terms of working well, not requiring significant repairs of any kind. So the overall longevity and having to reinvest in them, it shouldn't be a big issue.
Thanks, Hank. There was whoops, I scrolled and I lost it now. It was about the DTE. I had just bought an electric car, and wow, there's so many questions, folks. Thank you all so much for your participation. We're trying to get to all of these. And I lost this one because there's so many. That was asking if they need to get a second meter to get certain DTE rebates after installing their EV charger.
I believe DTE can provide you an EV charging rate, but they want to put your EV charger on a separate meter to ensure that they're separately metering its usage and providing you a separate rate. But they provide the meter.
Okay, there are still so many questions. If there are any that any of our panelists would like to elevate, I think now would be the time. And if not, we might.
There seemed to be a number of questions about solar that I could probably answer pretty quickly. One was about DTE limiting the amount and how and why can they do that, so that they can do that because they have to come out to your house after you get solar. They have to come out and do like there's an interconnection agreement, because you're going to be, unless you're off grid, which most of us are not, you're going to be backflowing into the grid. So they have to approve it, and they don't want anybody to have more solar on their roof than they use in an annual 1-year span of time. That's anyway, that is what it is. And so they limit how much solar you have based on the last year's consumption of electricity. If you then add to your electric load by getting an electric vehicle or something, they will allow you to increase your solar and add more panels. So what I recommend when I'm working with people getting solar is that if that's the plan, that in 2 years, 3 years, I'm planning on this electrification or that you talk to the installer when you're getting your solar, because they can create a system that is ready to accept more panels by sizing up the inverter or by system design, that kind of thing. So just kind of keep that in mind when you're talking to your installer. And then I think there was one about them paying you for your excess generation. So DTE pays in an inflow outflow model, which basically means that when you're taking energy from the grid, you're paying full retail rate for that electricity. But when you supply energy to the grid, because you're not using it all at that moment, like on a bright sunny May day, they pay you about half retail rate for what you overproduce. So I know behaviorally, I, with solar, have started using all of the electricity that I can when it's very sunny out. So I'll do my dishes and my laundry with my heat pump dryer and charge my car in the middle of the sunniest days when I can, to try to use as much of that behind the meter as possible.
Thank you, Julie, for the solar background. And on that note, we started at 6:02 and it's almost, and there it goes, 8:02. So I just want to say thank you all so much for joining us and for your participation. Clearly, this is a topic of interest with the amount of questions that have been submitted, and I'm so sorry that we weren't able to get to all of them. But I have changed my title here to the email address where you can send questions. Please stay in touch with us and let us know what other questions you have. And we would love to answer some of those questions for you. In the meantime, we look forward to seeing you next month at where Sean will be presenting the sustainability of food and food access. So thank you again also to our presenters, Mac and Henry. And when I'm looking at your name, my brain crossfires. From Michigan Saves and Elevate Energy, respectively, and all of you for your engaging questions. We look forward to doing more with electrification. By the way, it's strategy 2 of A2ZERO is to electrify. So I think I forgot to mention that part, but it's something we're working hard on and we need your help. So please engage with us and send us questions that you have. Any final thoughts, anyone?
Zach, you're awesome. Fantastic.
Yeah, we're going to start a podcast with whoever it was in the, I think it was Steven something. So cool. We'll get the podcast going. All right, everyone. Have a wonderful evening. Happy Wednesday. Enjoy the rest of your week.